Hi everyone, and welcome to the surface area and volume of a cylinder video in GCSE Maths series. So let's get straight into it. So a cylinder, what is it? It has two circular bases and a height between them known as the vertical distance. So to draw out our cylinder, it looks something like this. And the best way to visualize it is either a can of Coke, Pringles, that sort of thing. It's just a pack of tennis balls, something like that, with two circular bases, one at the top, one at the bottom, and the distance between them with a curved area which goes around. So we have our height here and our two circles top and bottom, right? So once again, if you haven't watched our surface area video before, they basically describe surface area as the exterior of our shape, right? If we wanted to wrap our shape in tin foil or wrapping it up for Christmas as a Christmas present, how much area would we need? How much would it cover? How much wrapping paper would it cover to cover the whole outside of our shape? So that's the way you can think about it. It's to do with the exterior to calculate all the area within the shape. So the first part of the formula might be quite simple to you guys. Pi r squared and pi r squared, the two areas of the top and bottom circle. 2 pi r h comes from the curved surface around, which wraps around our 2 points, wraps around our two circles, sorry. So hence we get the formula 2 pi r squared plus 2 pi r h, because this is the area for curved surface, and this is our area for two circles. So if you watch my video on volume of a prism, where we discussed that to find the volume of a prism, we just find the area of the cross section and times through by the length or the height. This is essentially a circular prism, right? So to work out our cross-sectional area, and our cross-sectional area is just a 2D image which determines the shape of the 3D image. So obviously this is a cylindrical thing, it's a 3D circular object, and the 2D image which determines that is the circle. Hence the cross-sectional area is equal to pi r squared. Then to times through by our height is what we need to do next. And the way to think about it is, imagine our 2D shape to be a piece of paper in the depth or the thickness of a piece of paper. So it's essentially 2D, completely flat. How many of those 2D cross-sectional areas could you fit within the 3D one if you lined them up back to back? That is our volume. And another way to visualize volume is, say, how much water can you put within a swimming pool, within a glass, that sort of thing. It's to do with capacity, like how much can you hold within the 3D object, whereas surface area is to do with outside, volume is to do with inside. Okay, now to take a look at some questions, and we're going to start off with surface area. So a cylinder has a radius of 2 centimeters, right? And a height of 8 centimeters. The radius is 2, and calculate the surface area and leave your answer in terms of pi. If you recall our formula, which was 2 pi r squared plus 2 pi r h, now we plug in our values. This is our height, this is our radius. So we go 2 times by pi times by our radius, which is 2 squared, add 2 times by pi times by our radius, which is 2, times by our 8, which was our height. And we end up with this part is going to be 2 squared times by 2 times by pi, leaves us with 8 pi. And this part here is going to leave us with 32 pi. Hence, when we add them, we're left with 40 pi. And remember, we're dealing with surface area here, is to do with area, so centimeters squared. So I'm going to write that up here. 40 pi centimeters squared. Okay. Now, I'm going to leave you guys to have a go at intermediate and challenge. Then play the video once you've completed it and check your answers back. So, a can has radius 3.5 centimeters, right, and a height of 10 centimeters. Find the surface area of the cylinder. Same thing again, 2 pi r squared plus 2 pi rh. Plug in our values for r and h, and we get 2 times by pi times by our 3.5 squared. Add to our 2 times by our pi times by our 3.5 times by our height. And this leaves us with 3.5 squared times by 2, which is 49 over 2 pi. Add to 3.5 times 10 times 2, which is plus 70 pi. 70 plus 49 over 2 leaves us with, 244.4. Oh wait, no, sorry, I've made a calculation error. This is going to leave us with, to one decimal place, 296.9 centimeters squared. That should be the answer that you got. So 296.9 centimeters squared. Okay, so looking at the next question, I have just realized that this is a question that I use for more advanced students. It involves some very technical maths, and so I'm going to leave this question out for today. But please, if you had a go at it, let me know in the comments if you had any difficulties, and I'll tell you how to do it. Essentially, we need to form a quadratic equation and use the quadratic formula and choose the positive root always, and get your answer that way. But obviously, today's a more relaxed, not relaxed, lesson for the less advanced. So we're going to just move on to volume questions now. So it tells us that a cylinder has a radius of 3 centimeters, 3 centimeters, and a height of 10 centimeters, as such there. And now we need to work out the volume. So remember, with volume, it's all about the cross-sectional area times by our height. So our formula is pi r squared h. So pi times by our radius, 3 squared, times by our 10. So pi times by our 3 squared times by 10, 90 pi. And it wants it in terms of pi. So we leave it like that. We don't need to expand it anymore or simplify it more like. Yeah, so moving on to question 2. You can have a go at these 2 questions next and leave your answers in the comments, or not leave your answers in the comments. Well, you can, but play on for your answers. So we have a radius of 4.5 centimeters and a height of 12 centimeters. So to calculate the volume, we simply do pi r squared h, which is going to be pi times by 4.5 squared times by 12. So pi times by 4.5 squared times by our 12 is going to be 243 pi, and they want it to 2 decimal places, so we were going to give it as 763.41 centimeters cubed. And I forgot my units up there. Don't do that, otherwise you won't do very well. But yeah, easy mistake that is. So looking at question 3, a cylindrical water tank has a volume, so V, of 1,100 centimeters cubed. It has a radius of 5 centimeters, and we need to work out the height. Okay, so let's draw out what we know. We know that the radius is 5 centimeters. The height is unknown, so we leave it as h centimeters, and the volume is 1,100. So you may be thinking, how do we approach this? Like, we don't know the height, how can we use the formula? Okay, so let's write out what we know, right? So pi r squared h is equal to 1,100. We can actually reuse this formula because the formula is an expression of the volume, and we actually have the volume, so we can work backwards in this case to find our h. So if you were to think about our formula as an expression, as a representation of the volume, and 1100 is the volume, we know that at some point, for some values for radius and some values for height, that we know that pi r squared h is going to be equal to 1100, right? So we can use this and plug in the values that we know. So pi times by 5 squared times by h is equal to 1100. Okay, so that means 25 pi times by h is equal to 1100. And now this is a simple equation. We just want it to work to equate to h so we can find out our h. And the way we do this is to get 25 pi on the other side, and we do this by dividing. So h equals to 1100 divided by 25 pi, which is equal to 14.0 centimeters to 1 decimal place. So that's going to conclude our video on surface area and volume of a cylinder. Hope you guys enjoyed. Hope you guys learned something. Please like, comment, and subscribe. And I'll catch you guys in the next one, whenever the next one is going to be. And peace.